Yeah, good one. We are presenting on fuzzy logic algorithm in AI. So, fuzzy logic is a way of making decisions that mimic how humans think. So, instead of saying the normal traditional logic way of saying things like which is true or false, so this fuzzy logic introduces so this fuzzy logic allows for some degree of truth. So maybe something like a partial truth or mostly false. So this helps in real world situations where things aren't just black or white. For example, instead of saying something is false or good, fuzzy allows us to describe the temperature as warm or slightly hot. This phenomenon was introduced by Defuzzification. He was an Azerbaijan and also an American, so he was having dual citizenship. He was born in 1921, and he introduced this logic in 1965, which helps in providing exact inputs to intelligent systems.
Instead, fuzzy logic used with some level of certainty or uncertainty. Different from digital logic, which deals with only true or false. When you do with fuzzy logic, it gives you some level of certainty, some range. So the difference between the two of them, we say it's just 0 or 1, that's yes or no. Then we can have some possibility in between. So, this is the architecture of the system. Just like how any other digital system works. You give it an input, it comes to a system where it will be declassified, that will give you into the range of certainty. Then you get the intelligence, which is having some basic rules. Okay, then it will be turned back into a physical output. Just like in digital system where you get a converter into digital and just like that. So if you are trying to apply fuzzy logic in real life, comparing it to digital logic, if this is a digital logic, we can only say that, okay, if this red card here is 5 meters, 1.5 meters away from this blue card here, that means we are close, so we should stop. So it means that if we are using digital logic for such a system, then braking will be prompt. So in AI system where we are trying to get artificial intelligence to drive our vehicles, using digital logic will make the driving a bit uncomfortable. But let's say when we apply the fuzzy logic, it means that we can tell it, oh, okay, if you are 1.5 meters away from the blue car, you are close. But how close? You are, let's say you are very, very close. So at that instance, we can introduce another logic to say, okay, if you are very, very close, then you can stop on to. But if you are very close, you can decelerate. And if you are far, that means you can accelerate.
The process of turning the grapes input to a fuzzy value, that's the membership grade. It is similar to how the age of humans are collected and classified into baby, child, teenager, or adults. Okay, so we have the level of distance and the speed. So 0.25 of the small is equal to the speed is not very low. 0.888333 of the medium. That means it's a small speed. And 0 of the large that means the speed is definitely not high. One says if distance is small, then the speed is low. And rule 2 says if the distance is medium, then the speed is steady. So rule 3 says that if the distance is large, then the speed is high.
Computations in either discrete or continuous case. In the discrete case, it's either u into bracket x1 divided by x1 plus. But here, the division sign and the addition sign, they don't have their normal meanings. They just act as separators to separate this member from the other one. So ux2 divided by x2, it means the numerator is the membership value, and then the denominator is the participation. Now, we move on to the rules. That's after converting your fuzzy logic into the intelligent engine. We need rules or a set of knowledge base to combine it with the input. So this is a database consisting of linguistic rules that's in the if-then format. Now it takes if premise, that's the antecedent, then a conclusion, or it concludes on the action to take. Now, this is fully made up of if-then rules, as I said already. Then using the if-then rules in knowledge base, it performs reasoning by producing an output. Now, before you can evaluate a particular system, you need 2 stages, that's rule evaluation and rule application. Then, in the rule evaluation, we use the operators and or and not.
Advantages of the fuzzy logic. Some of the advantages are you can handle uncertainty and imprecise data. Unlike the traditional logic, whereby you have to it takes only the inputs are only zeros and ones. The fuzzy logic can take from imprecise data and partial field. And the second one is it is more flexible than the traditional binary logic. It's more flexible. But the traditional binary logic only take what? Only take the zeros and ones.
This is a fuzzy logic system. Fuzzy logic is heavily criticized as opposed to probability and classical logic due to its relatively nature. Different people have different meaning of small, medium, steady, and low. How do you find them? How do you explain these things to computers? Also, it requires a large computation and memory size, and the accuracy is sometimes more precise because we use imprecise data.
The final step in the fuzzy system, where decisions needs to be made based on fuzzy logic source.
So, I'm here to present you some applications of the fuzzy logic. One, that is, it helps in control systems. The fuzzy logic is used to control complex systems such as temperature control, speed control, and robotics. Also, it is used in natural language processing. That is, the fuzzy logic is used or is applied in the natural language processing to handle ambiguities or uncertainties within the language.
Limitation. Limitation. We have a lack of standardization and difficulty in defending membership function and computation, complexity.
In summary, fuzzy logic is a powerful tool in AI that can handle uncertainty and very imprecise in data. It has a wide range of applications.